Hey guys! In this lesson, we would understand another applications of quadratic equations that involves area problems. And the question is, a triangle has a base of 2x plus 1 and height 6x minus 3. Find the value of its base and height that would give an area of 240 meters square. Round the answer to the nearest hundred. Because we are given the base of a triangle, so let's say this is how the triangle looks like. The base of the triangle we are given is 2x plus 1 and the height always means perpendicular height, is given to us as 6x minus 3. We are supposed to find out the value of its base. So the base and the height is given to us in the form of variables. In order to find the value of its base and height, we would need to find out the x value. So once we know the x value, we can sub in the x value in the base. 2x plus 1 to get the value of base, as well as we can sub in the x value and height to get the value of height as well. Now, in order to find out the value of base and height, they have given us the area of this triangle as 240 meters square. We know area of triangle is equal to base times height divided by 2. Base is given to us as 2x plus 1. Height is given to us as 6x minus 3. The whole thing divided by 2, and we're given the area as 240 meters square. Now we have to solve for x, and if we want to solve for x, we have to isolate x. We notice that the x is at two different spots, and we have learned in one of the previous lessons that if x is at two different spots, then in order to solve for x, the other side should be equal to 0. Now let's see how to make the other side equal to 0. Let's first move this 2 on the other side. So 240 times 2, we would get 480 equal to 2x plus 1 times 6x minus 3. We cannot solve the x value until this is 0. So in order to make this a 0, we need to move this over on this side so that here we are left with nothing. Nothing means a 0. When this moves on the other side, it becomes minus 480. Now this equation looks kind of like factored form of quadratic equation, but this number, which is a separate term, is not letting us solve the x value. So what are we going to do first is expand this. So when we expand this, 2x times 6x and 2x times minus 3 would give us 12x squared minus 6x, then 1 times 6x, and 1 times negative 3 would give us plus 6x minus 3, and there is a minus 480 behind it already. So finally we will collect the like terms. When we collect the like terms, minus 6x and plus 6x gets cancelled out because they are the same terms with opposite signs. And we would collect 480 and 3 to get negative 483. Now this equation is equal to 0. And here we notice x is only at one spot, so it's easier for us to solve for x just by isolating it. Then we will move this on this side. So 0 plus 483 is 483 equal to 12x squared. X squared is equal to 483 divided by 12, and that would give us 40.25. Then we move the square on the other side, we get a square root of 40.25, and that is equal to plus minus 6.34. Because we have to round the answer to the nearest hundred, so we would write on two decimal places. Why do we put plus and minus sign? That means when we square positive 6.34, then also we get 40.25. And when we square negative 6.34, then also we get 40.25. Therefore, square root of 40.25 would give us both positive as well as the negative answers. That's how we get the 2x value. One is positive 6.34 and one is negative 6.34. However, we would rule out the negative 6.34 option because we are looking for dimensions. And dimensions cannot be negative. So we take the positive 6.34 value of x. X we've got is positive 6.34. So base of this triangle would be 2x plus 1 equal to 2 times 6.34 plus 1. That is equal to 13.69 meters. Why are we using the unit meters? Because the area was given to us in meters square. and height is equal to 6x minus 3, that is equal to 6 times 6.34 minus 3, which is equal to 35.04 meters. And this is how we get the dimensions of this triangle when we are given the area of the triangle and the dimensions in the form of a variable. All we have to do is just use the area formula, sub in the dimensions, and solve for x. Once we get the value of x, then we can find out the value of base and height.